In this first video in the Salvation series, we aim to give you an understanding of the structure of Salvation and the components that work within it. So, what we're seeing here, this is a grey blank window. I've come to File and New at the top and I get this window here. Now this is what we call an empty patch. So a patch is a collection of modules to create a specific function or feature. The modules are the individual components which, when brought together, create that total function or feature. AI and Salvation ship with a lot of modules in there by default, so if you right click and choose Insert Module, you'll see that there are many different modules for many different functions supplied with the software. We can choose one of those modules, we can place it and put it within our composition, our patch, like so. When we have multiple modules, we start to see different coloured ports on them. Let's get one of those in there. Okay, so we can see that we've got three main coloured ports here. Blue is control data. That could be a rotation amount, it could be a motion tracking signal, it could be a live Twitter feed, it could be anything at all. Green is flat, unmodified, two-dimensional texture. So think of your video or your still image not wrapped around a 3D object, just playing in your media player or your whatever application you use to play back your video footage. It's a two-dimensional piece of image. The yellow ports contain the OpenGL code, so this is where all the 3D stuff happens. The translating in 3 dimensions, scaling, warping, mapping, all the kind of cool stuff. Now we can also see that there are two different looking ports. So if we look at the yellow ones, for instance, the upper one of these two yellow ones, this is like a downwards pointing triangle. So think of this as an output. And the one below on the video out module, this is an upwards pointing triangle. So think of this as an input. Now Salvation is actually pretty intelligent and it's not going to let you make a bad connection. So for instance, if I try and connect an input to an input, it's going to say no. So I click and hold my mouse, drag to the new port, and we'll see that we get a no entry sign, as though saying you cannot place that cable here. But if I try and place that on a good connection point, the pointer turns into an arrow, as though to say, yes, you can place that cable in here, that's fine. Now the ports that we see, if I connect those two, we'll see that when the port is connected, we get a solid colour on the port, and I can actually hold my mouse over that connection and it will show me where that is connecting to. The ones without a connection in them have a black dot in the middle, so think of that as an empty socket. Now, as I mentioned, a collection of modules is termed as a patch. Now, if I have an existing patch, I can actually bring it straight into this patch, which means that if I have common functions or features that I use, I can use them from the library instead of having to create them from scratch every time. So just as an example, if I right click, I choose Insert Patch File, and then in my patches folder I'm just going to choose this first one here. We place that and we can see the patch. The way we can tell this is a patch and not a module is by the colour at the top of the unit. So we see the modules here, they have a solid blue top bar, whereas a patch has a grey top bar. So if there's a solid blue at the top, this means you cannot open this module any further, you're at its most base level. But if there's a grey header, it means you can actually go inside here and find other modules. So we can either right click on the module and choose Expand Patch, or we can double left click in a grey area of that patch, like so. And then we can see that inside of the patch we have these different components. Now when we have components in different windows like this, we need a way to transfer signals from the inside of the window to the modules outside of that little patch. And that's where this patch I/O comes in useful. The patch I/O is a patch in/out. Think of it as your cable run between the two different windows. Now we can only have one patch I/O per window, So I'll just add one in this window just to show you how it's added, because we've got one in there already. So right click, insert patch IO, and it's as simple as that. And then anything that I want to connect to the outside world, I just drag my connection to the patch IO and it will show on the outside of here. So just to take that one step further, let's see that actually happening in action here. I'm going to take the output from my brightness and place him here. Now this is the patch that we're inside here, and we can see that we don't see that new port yet. We only see the two that were previously there. So the easiest way, right click on the patch and go for reset skin, and we should now see all of those ports, including the out that I just added there. Sometimes you may want to group existing modules into a patch. It's quite simple. Grab the modules and use Control G to group them together, and you'll find that it places them all inside. It even gives us our patch IO, where it realizes that there's a connection to an external device already being made. You'll notice that when you hold your mouse over the port, you should generally get some kind of feedback as to the data or the image that is actually going through that port at a time. But you'll notice that as soon as I leave the port, I lose that preview of the image or the data. And sometimes you can want to lock your preview so that you can see what's going on at all times when you make adjustments. So at the top menu, we have View and Inspector. And Inspector works just the same as hovering the mouse over the port, but with Inspector the output will lock to that port. So we see here we're still seeing the output from that green texture port until I choose another port. So when I choose this blue port, the image will disappear and we'll see a value there because that's a value port, like so. And as I mentioned, it will lock to that parameter, that port, so even when I change the value we can see that port changing. So I often use Inspector as a signal chaser. Maybe if I have a problem with my output, I can chase my signal along and see what's going on, or just to test signals or data that I'm sending across the system.